So far in this course, and kind of really in a lot of places, you have been given the information that you need to be able to run a program. So we've done lots of things like creating folders and file structures on the command line. We've done things like using version control on the command line. We've done things like at this point, we're able to find files by name, and we're able to do things like filter lines from files using a tool that's called grep. And in all of these cases, at least within the context of this course, we've given you the information that you need to be able to run these programs. So not just the name of the program, specifically in the case of grep, but also we've told you about things like what are the options that you should be passing to accomplish this task. As you move forward in courses and as you move forward in your career, you're going to find yourself in places where you really don't have that anymore. You're going to have colleagues and peers that are definitely willing to help you with stuff, but you're going to have to figure this stuff out on your own at some point. And so, what we're going to do here is try to spend some time taking a look at how we can get help from the commands if we know the names of the commands themselves, how we can get help from the documentation that's installed on a system, so specifically a Linux or Unix based system. And then we're going to move on to how do I get information safely from the web? So, how do I start asking questions about how to run commands or how to accomplish the task using web browsers and search engines and things like ChatGPT? So, to start, what I want to do is spend a little bit of time taking a look at the commands and how to get help from the commands themselves. One of the major commands that we've been using in this course in the command line is git. And git, at least the way that we've been using it, is based a lot on sub commands. So when we run git, we never really run git by itself. Um, in terms of asking Git for help, this is actually one of the ways that we can ask Git for help. And this is a pretty common approach for programs where you are kind of required to tell them what you want them to do. When I run Git all by itself, it immediately prints out this usage guide. And what this usage guide is showing us is this is the way that you should be running Git. And Git is able to do this because without a command, it actually doesn't really know what we want it to do. So what this looks like is it starts by telling us usage. This is how you use this command. Here's the word git. This is what we typed in. Everything here that's in square brackets is an optional thing that we can provide to Git. We can see here that just like the find and grep commands that we were using before, there's these dash dash or dash options that we can use to pass behavior modification to Git. So these are options that we can ask Git to change its behavior. There are some that have the same symbols, like C here, uppercase C and lowercase c. These mean different things for grep than they do for Git, but they follow the same kind of pattern in terms of what an option is structured like. The one part that is required is placed here in angled brackets. Sometimes it doesn't have angled brackets and sometimes it does, but the angled bracket notation here is saying this is a required thing. If you're going to run Git, you have to put the command that you want to run here. Let's take a really quick look at this because we've talked a lot about version control and we don't really need to talk too much more about it, but it gives us some basic information about how to use Git. So to start a working area, we've used clone. We didn't use init in this course, but this is another way to create an empty repository without using something like GitLab or GitHub to initialize the repository. There are commands for working with your repository. So we did things like add and restore. There are also things like move, which will do what you expect it to do, move a file, but it means that Git will do the move operation and it will also keep track of that move operation in its history, as opposed to having to move it with the move command and then commit it later. RM does the same sort of thing. Examine the history and state. So we didn't really talk about bisect. We didn't talk about grep, but at this point you should know what grep does. We didn't talk about show, but we have used status, log, and diff before. We've done things with branches. So we've used branch, we've used commit, we've used merge, we've used switch. We didn't do rebase, reset, or tag, but that's kind of outside the scope of this course. And then in terms of collaborate part here, we've done push and pull. We haven't done fetch, but fetch is effectively the same thing as a pull operation, except it doesn't actually update the files in the branch that you're on. It just updates the metadata that Git keeps track of for your files. There's one thing that I do want to step into here, which is it says see also Git help tutorial. So I'm going to run that, Git help tutorial. This takes us into something called a manual page for Git. We're going to look at manual pages in a couple of minutes, but this is a way that we can continue to get help from Git just by typing in Git with no other options or arguments. And this little manual page here will take us through how to use Git from the beginning. I'm going to quit out of here by pressing Q on my keyboard, just like it says to do on the bottom. And then what I'm going to do is I want to run another command. So first I'm going to change into my comp1002 directory, so COM and then tab. And I'm going to type ls on my keyboard. ls, if I run this by itself, doesn't print out help information. ls is a command that we use so frequently that the default behavior of ls is to print out the current working directory's contents. We can actually explicitly tell ls to do that. So I can say ls space and then period. I would like to print out the contents of the current directory, and the output here is identical. The people writing ls recognize that this is such a common operation that having to type in space and then period every single time that you wanted to print out the contents of the current directory would get really frustrating and annoying. And so the default behavior of ls is to just print out the current working directory. The problem with this is that if I type ls, unlike Git, I can't get any help about it. But we know that there are other options on Git. We know that there's on ls. We know that there's more things that you can ask ls to do, and there's more things that you can ask ls to do in terms of changing its behavior. On Linux systems, we can pass ls this --help option. And --help is a pretty common option to pass commands when they don't print out usage information if you are just typing in the name of the command by itself. This has printed out way too much information, and I'm gonna use a small little tool here to help me be able to see everything that this is printing out that's called a pipe. We're not going to talk about pipes in this half of the course, but you can see them in the second half of the course going forward. The pipe symbol is the same as the OR symbol in programming languages like Java and C. This is something that you can get by pressing Shift on your keyboard and then pressing the key that's basically just right on top of the return or enter key. What this says is I'd like to take any output that ls prints to my terminal, and I'd like to send it instead to a different program. The different program that I want to send it to is called less, and less is a pager. I'm going to press enter here. So what we see here is pretty similar to what we saw with Git. It tells us usage ls, the name of the command, and then optional, so these are square brackets again, all of the options, and then all of these are the options that we could put into ls. And then the file. So we can actually pass a file if we wanted to, but again, the default option is just to print out the current directory by default right there. A lot of these options they're here. It tells us how they work. So -a says print all, do not ignore entries starting with dot. $A is almost all, do not list implied dot and dot, but print everything else that starts with dot. We have also seen the -l option. So I'm going to scroll way down here to find -l. This says use a long listing format. But then there's other stuff here that doesn't really actually tell us much about what it does. So this -h, for example, says dereference command line, follow symbolic links listed on the command line. There's a lot of stuff here that we don't really know about in terms of what this course is, but it's not particularly helpful. I'm going to quit this, And what I'm going to ask to take away from this is that if I pass this dash dash help option, it's going to print out a long list of the options that we get from it. The ls command is actually reasonably helpful in that it tells us basically what each of these options does. Another command that we've used to be able to find files on the command line is find. On a Linux system, when I press enter, it actually just prints out all of the files that are in this current directory. On Mac OS systems, you have to do find space period, and I've kind of been advocating for you to use it this way anyway, but if you don't pass an argument on a Linux system, it does the same thing as what ls does. Print out all of the files under the current directory. Find every single file under the current directory. Find also has a dash dash help option, just like ls does, but it's surprisingly small and incredibly unhelpful. It does have the same general pattern: usage, the name of the command. These are optional arguments, but it doesn't explain what they are. It tells us that we should give it a path optionally. The optional path, the default path here is the current directory, it says, and then something that's called an expression. This is also optional. The expressions that we have been passing are things like dash name. There's a bunch of other stuff in here that it's actually not clear immediately what this does. There are operators, and we know a little bit about what these are based on programming languages, but things like dash a or comma don't really help us very much. There's a bunch of other information here, tests, and then it lists lots of things: a min, a newer, a time, I whole name, no group, no user, whole name, used, and it's really unclear what all of those things are. Then there's the action sections. We've actually seen delete, and we have actually seen exec before, so we have a sense of what those things are, but all of these other options, it's kind of not really clear what all of these are supposed to mean. So passing dash dash help is one way to get help from this command, but we can get even more help from something called the manual pages. So I'm going to type in a command here called man. When people talk about manual pages, they often refer to them as just the man pages. And the reason that they're being referred to as the man pages is that the command you use to open the manual page is just man. That's why we're using it this way. I'm going to say man find. So I can type in man and then the name of the command that I want to get information about. This prints out lots and lots of information. We're going to take a look at a few different parts of this. So at the top, we see there's the name of the command that we're looking at, and then there's a number here. We'll talk about that in just a second. There are also then sections about this command, and the sections you can kind of expect to see in every manual page for every command. So it tells you the name of the command. The synopsis lists out approximately how you should be running it. So this is that usage statement that we saw at the beginning. The description tells you about the command itself. So this is for the GNU version of find, and you'll actually, if you run this same command on Mac OS, you're going to see that the output here is a little bit different than from this because it uses something called the BSD version of find. Then it lists the options, and here it's actually completely explaining what these options are. So dash P and dash L and dash H all have to do with something called a symbolic link. We're not going to talk about symbolic links in this course, but the short of it is that these are shortcuts. This is a way for us to represent a shortcut between places on a folder or a file system without using like desktop shortcuts and icons. So this then comprehensively tells us that. It tells us about this dash D option. What are the options that I can pass to that? And then the level. So query optimization tells find how it can change its behavior to speed things up a little bit. The next part is, now this is unique to find, and it says this is expression, and it tells us about what this expression thing is inside of the find command itself. Then it starts telling us about each of these different subsections. So positional options, it's going to tell us about global options, it's going to tell us about tests, it's going to tell us about more and more stuff. So this is all now unique to the find page, but it does comprehensively list everything that we need. The find manual page also has an example section, and this isn't a universal thing across all commands, but it's something that you can find in the find manual page. So I'm going to press / on my keyboard to search for stuff, and then I'm going to search for uppercase examples and press enter on my keyboard. The first few things that we find here are not helpful, so I'm going to press N on my keyboard to move to the next place that it's found. And the thing that I'm looking for is this part right here, where it lists a bunch of different examples of how to use find. Some of these are like actually quite helpful because they tell you how to use certain things and how to do different things for those things that we want to do. So it tells us, for example, how to use the find and exec option. It tells us how to search for files by permissions. So we were changing permissions pretty recently, and this is going to give us a way to be able to find files that have certain permissions, or as we'll see in a little bit, files that don't have certain permissions. The manual pages are comprehensive. They are comprehensive in their output. I'm going to quit out of this manual page by pressing Q on my keyboard, just like it says. I'm going to open up the manual page for find one more time here. And the last part of the manual pages stuff that I want to talk about is this number up here. So this is telling us what section of the manual page this page is coming from. The manual documents have 7 different sections in them or more, depending on the system that you're currently looking at. So on Linux systems, it actually goes up to 9, but on other systems, it may be 7 or 8. The ones that we really care about are the first just few sections. I'm going to quit out of manfind. And what I'm going to do is I'm going to run the manual page. I'm going to search for the manual page for a command that's called write. So what we get as the default option here is section 1 of the manual pages. So write is the name of a program. Section 1 of the manual pages is filled with information about user commands. So these are the commands that you would run on the keyboard, on the terminal to do stuff. Write is sending information from one user to another on the command line. I'm going to quit this. There's actually another manual page that is also for something called write, and that's in section 2 of the manual pages. Section 2 of the manual pages is for system calls, and this is something that's important when you're taking a course like operating systems. This gives you documentation about how to use a function that's called write. So section 1 is for commands that you run in the command line. Section 2 is for system calls, and these look a lot like functions that are on the command line. These are pretty low level. This is where you're basically interacting with the operating system itself, but it tells you how to use that command, how to use that function, what it returns, and what its function signature looks like. I'm going to quit out of this manual page, and we're going to take a look at another section called section 3 of the manual page, and we're going to look at something for fgetS. fgetS is a function that you'll call in C if you want to get strings from a file. Section 3 of the manual pages is for functions that fit into the standard library. So this is a slightly higher level than the system calls that were in section 2. The distinction here is not important for this course. The distinction here happens when you start learning C and then when you start learning about the operating system interface. But section 3 also has functions that are listed here with their signature and what you should expect to do in terms of being able to call them. Section 4 of the manual pages is about special files that are on the command line. So if I do man for random, this is going to print out section 3 of the manual pages because this is the first one that's installed on this particular system. Depending on which shell you're using, you might actually get different outputs here, but this tells us about section 3. If I do man for random, this actually starts telling us about special files that are on a Linux system. So /dev/random and /dev/urandom are special files that you can interact with on Linux systems to be able to get random numbers, to generate random numbers. Section 5 of the manual pages is for special files. So I'm going to type in section 5, man5fstab. This is printing out information about a special file that's called the file system table. and it tells you what you need to type into this particular file. So it's in /etc or /etc or /etsy. And then this is the name of the file that you would write in, and it tells you how to use this file to be able to take hard drives on your system and make them appear as folders. I'm going to quit out of this. Section 6 is for games, and I don't actually think there are any games installed on here. I'm going to do man6 NetHack, but I don't think NetHack is installed on these systems, so it's not. If you install NetHack, this is a terminal-based game that you can play. Don't install it; you'll just waste lots of time. The last thing that I want to run is for Section 7. So Section 7 is for kind of like big concepts in Linux and Unix system. I'm going to run man7 signal. And what man7 signal does is it gives us an overview of the whole idea of what signals are on a system. Again, this is kind of outside the scope of this course and not really something that you'd see until you get to operating systems. But what you can see here is that it tells you to look in other sections of the manual page, like to send a signal to the calling thread. You should look at section 3 of the manual pages for this function that's called raise. If you want to send signals between processes, you should look at section 2 of the manual pages for this function that's called kill. The last thing that we'll look at here in terms of sections of the manual pages is section 8, which is for administrative commands. sudo is not something that you will run on Aviary. It's not something that you will run on systems that you do not own. But this is something that you will need to do if you want to, for example, install software on a Linux system for the entire system. This is kind of like Windows popping up that little dialog that says, are you sure you want to do this? And this is kind of like what happens when macOS pops up that dialog and asks you to type your password in when you're trying to install something at the system level. The very last thing that I want to take a look at with man is the option K here. K is the way for us to search for something. So everything that I've just been talking about in terms of manual pages assumes that we know what we're looking for in the first place. So I know the name of the command find, I know the name of the command write, or the name of the function write, I know the name of the function fgetS, I know the name of the command find, or I know the name of a particular page that I'm looking for. Man-K lets us search for things, and we can search for things by typing in -K and then the name of the string that we want to search for. So if I type in man-K and then search, it will print out all the stuff that will have the word search in it. You can find out more about man by looking at the manual page for man, and you do that by saying man, and this will tell you about all the stuff that you can do with it. So for example, man-K here is apropos. So this gives us, kind of says like, tell me what you want to search for here on this regular expression. In terms of searching for help on the command line, the main ways that you can approach this are try running the command with no options or arguments. If you can't run the command with no options or arguments, try passing -H or --help. If that's helpful, great. If not, then you can start taking a look at the manual pages, recognizing that sometimes you'll have to switch between manual sections to be able to find the thing that you're looking for. If you don't know the name of the command that you want to use, then you can use the search option on the manual pages to be able to start finding information about something that looks like what you're trying to do.